Okay, for lesson 3, as you can see here, we're going to talk about manipulating or changing or working with two variable linear equations. And we're also going to talk about graphing a line using the intercepts. So to start off, let's look at the three main forms of a linear equation. Now these aren't the only forms that are possible, but these are the three main forms that you will see as far as an organized form that has some kind of a specific format, the way it's supposed to look. So there's slope-intercept form, which we've talked about. There's standard form, and then point-slope form. Now we'll get into these a little bit more later, but for now just be slightly familiar with these three. Okay, so standard form, you can see this equation up here at the top. ax plus by equals c. And the stipulation is that a and b have to be integers. So on the left side here of your screen, I have some examples of standard form. Okay, notice that in each of these equations, a and b, which in this case would be the 2 and the 3, -3, or in this case they're both 1s. In this one there's no y term, so b is 0. In this one there's no x term, so a is 0. And the last one, c is a fraction. That's okay. But a and b are integers in all of these. Over on the right there are non-examples, and you can see that in each of these there's some reason why it's not standard form. In this first one, as an example, it's not standard form because the x and the y terms aren't together on the left side. So that the y is over here, but the x is over here on the right. This one's a non-example because the a number is not an integer. It's a fraction. It's a rational number. This one for the same reason. And then this last one is slope-intercept form. So let's look at an example here. We're going to change this equation from this form, and we're going to change it into slope-intercept and into standard. So slope-intercept form, to change that into slope-intercept form first, what I want to do is expand this stuff on the right. So I get y minus 6 equals -2x plus 6 if I distribute the -2. And then I'm going to add 6 to both sides, and I get y equals -2x plus 12. So this is slope-intercept form. It's the same line as this one. So if I graph this and I graph this, or if I made a table of values for each of these, they would be identical. Now let's change this equation into standard form. So I want to start out with the same thing. I want to expand the right side, so I get -2x plus 6. And then I'm going to add the 6 to both sides because I want the numbers all on the right. So y equals -2x plus 12. And then I'm going to add 2x to both sides. And the reason is because I want to have the x and the y terms together on the left side. So I get 2x plus y equals 12. Okay, so all three of these equations, this one and the slope-intercept form and the original one, are all three the exact same line, just three different forms of the same function. All right, so let's do another one that's the same. Okay, so this one I'm going to distribute on the right. So I have -3x, that equals 4y plus 2x minus 10. Now the other thing I want to do, this one says standard form. So I want to get the x term from this side over and combine it with these. And then I want the y term on the left side as well. So I'm going to do two steps in one. I'm going to subtract 4y from both sides and 2x from both sides at the same time. So minus 4y and minus 2x. Now you can see over on the right side, those add up to 0. So on the left, what I have is -5x if I combine the x's. -3 minus 2 is -5, minus 4y, and that equals -10, and that is standard form. Notice that a and b are both integers. Slope-intercept form, I'm going to start out with this right here. So I have -3x equals 4y plus 2x minus 10. And then slope-intercept form says that I want the y term by itself on the left, and then that equals something x, and then a number. So I'm going to subtract 4y from both sides to get the y over on the left side. And so I have -4y minus 3x equals 2x minus 10. And then I want to add the 3x to both sides so that I can get all the x's together over here. So I have negative 4y equals 5x minus 10. And then the last thing is to divide both sides by negative 4 so that I have just y. So those divide and give me 1, so I get y equals, this is going to be negative 5/4 x, and then negative 10 over 4 is going to be plus 5 over 2. 10 over 4, 5 over 2. Just as a quick review, let's review how we graph this line using the slope and the y-intercept. So the y-intercept will be negative 5, so I'd have a point here, and then the slope is 2/3. So remember, rise over run, so I'm going to go up 2 over 3, and then up 2 over 3, and I could do that as many times as I needed to, and end up with a representation of this function on the graph. Now, if an equation is in standard form, we can do something a little bit different. Instead of having to convert this into slope-intercept form and then graph it like I just showed you, we can use the intercepts. Okay, remember the intercept of a function is the place where the function either crosses the x-axis or the y-axis. So it's a point where the graph intercepts the x or y-axis. Now here's something important to think about. If I have a point, let's just say here, okay, that's a y-intercept. What I know is always true about every point on the y-axis. This is a very important point for you to get and to make sure you have in your notes. So this point, the coordinates are 0, 10. This point right here will be 0, 8, 0, 7, 0, 6, 0, 5, 0, 4, and so on. So on the y-axis, every single point has an x-coordinate of 0. So a y-intercept always has a 0 for x. On the x-axis, the coordinates would be negative 10, 0, negative 9, 0, negative 8, 0, negative 7, 0, and so on. So on the x-axis, the point always has a y-coordinate that is 0. So an x-intercept has a y that is 0. Okay, so a y-intercept has a 0 for x, an x-intercept has a 0 for y. So if I take this equation, 2x minus 5y equals 20, and I want to know where's the y-intercept, well, I just learned, or I just realized that the y-intercept occurs when x is 0, or there's always a 0 for x on the y. Then I can replace this x variable with 0 and find out what the value for y is. So if x is 0, let's cross out that, or let's hide the 2x term. I have negative 5y equals 20. If I divide both sides by negative 5, then I have y equals negative 4. So the y-intercept of this line is negative 4. Now if I want to know the x-intercept, let's hide the y term because the x-intercept occurs when y is 0. So if y is 0, that term goes away. So I have 2x equals 20 or x equals 10, and so I have the x-intercept right there. And now I have 2 points that I know are on this line, and I can connect them and get a rough sketch of this function. Okay, so once again, real quick, the x-intercept occurs when y is 0, the y-intercept occurs when x is 0. And so I can put a 0 in for x, solve for y, put a 0 in for y, and solve for x. So let's do this with a few more of these here. Okay, I'll graph this one with purple. Okay, so if I make x equal to 0, I have negative y equals 6. So the y-intercept is negative 6. So there's a point there. If I make the y equal to 0, I have negative 2x equals 6. So x equals negative 3. There's a point there. And that gives me a sketch of this purple line. Okay, the next one I'll graph in red. So if x is 0, y is 3. If y is 0, x is 4. So the red line crosses right here. Then this next one I'll graph in blue. So if x is 0, y is 4. If y is 0, x is 2. And so I get that. You can see how quick this is. Relatively easy. This last one, which I'll graph in green, if x is 0, y is negative 2. So on the y-axis I have negative 2. And if y is 0, x is 2. And so I have a shared point there between this one and the blue one. And that's it. So graphing by intercepts is easy. Now the equation doesn't have to be in standard form for you to use the intercepts, but standard form makes it probably the easiest out of all the forms to use to graph by finding the intercepts.